Welcome to This Explainer. If you are someone who loves to just cut right through the noise and get straight to how complex systems actually work under the hood, well, you're in the exact right place today. We're going to take a really fascinating journey into the architecture of Avalanche. Now, you know the drill. Every major blockchain out there promises to solve the infamous trilemma, trying to perfectly balance speed, security, and decentralization. But Avalanche? They tackle it in a completely different way than their peers. And honestly, understanding how they do it is absolutely crucial to understanding the next generation of decentralized tech. Let's dive in. So consider this. What if there were thousands of blockchains, each optimized for its own specific job, but all completely connected? It's a pretty provocative thought, right? It instantly challenges that traditional one-chain rules-all mentality we see so often in the crypto space. It really forces us to think beyond the limitations of a single network bottleneck. As the foreword in the Avalanche Deep Dive puts it, every blockchain promises to solve the trilemma. Avalanche actually tried something new. Instead of just choosing pure security like Bitcoin or raw speed through bulky Layer 1 hardware scaling like Solana, Avalanche bet on a completely unique plural architecture. They didn't just tweak the variables, you guys. They literally changed the entire equation.
Okay, here is our roadmap for today. 1. A new way to agree. 2. 3 chains, 1 network. 3. Scaling with custom subnets. 4. The fuel, AVAX tokenomics. And finally, 5. The multi-chain future. Let's get to it.
Section 1. A new way to agree. Solving the all-to-all voting problem. 100 million. Think about that number for a second. That is the massive amount of messages needed if you have 10,000 validators just trying to talk to each other in a classical consensus model. It scales quadratically, which is what engineers call an O of n squared problem. Basically, everyone has to talk to everyone just to agree on the very next block. And that is exactly why older networks can feel so sluggish and congested. The math simply breaks down at scale. So how on earth does Avalanche fix this? Well, instead of broadcasting to absolutely everyone, Avalanche uses sampling. Here's how it flows. Step 1, a node gets a transaction. Step 2, it asks just 20 random validators, hey, do you prefer this? Step 3, it adopts the majority view of that small group. And step 4, it repeats this process until the whole network converges. It's kind of like town gossip. If I hear a juicy rumor, I don't grab a megaphone and yell to the entire town. I just tell 20 friends, they tell 20 of their friends, and suddenly, the whole town is on the same page. This snowball sampling lets thousands of nodes reach consensus in under 2 seconds. It's seriously impressive. Now, how does this translate into real-world trade-offs? Let's look at Ethereum proof of stake versus Avalanche consensus. Ethereum requires 2/3 agreement in all-to-all voting. It prioritizes safety above all else. If the network splits, Ethereum literally halts to ensure nothing incorrect gets recorded. Avalanche, on the other hand, prioritizes liveness. By sampling those small, random groups, if the network partitions, both sides just keep running, and when they reconnect, they heal, with the heavier side winning out. To be clear, neither design is strictly wrong. They are just distinct, valid engineering trade-offs. Ethereum chooses to halt for absolute safety. Avalanche chooses to keep running for absolute liveness. Section 2. 3 chains, 1 network. The macroscopic view of Avalanche. Okay, to really grasp this, we have to understand the primary network. This is the core of the Avalanche ecosystem. But it actually consists of 3 distinct blockchains, and all of them are validated by every active validator on the network. So Avalanche isn't just one chain right out of the box, it's actually a team of 3.
Let's break down what each of these chains actually does. First, the X chain, or exchange chain. This is built for super fast UTXO transfers, which is similar to Bitcoin's transaction model, handling about 4,500 transactions per second. Centralized exchanges use this to move assets around really fast. Next up is the P chain, or platform chain. You can think of this as the main control panel for staking your AVAX and managing the broader network. And finally, we have the C chain, or contract chain. This one is EVM compatible, meaning it shares Ethereum's code logic. It's totally ready for MetaMask, and it handles most of the DeFi and NFT activity. So while everyday users might just think of the C chain as Avalanche, developers actually get 3 highly specialized tools working together.
But why build it this way, right? It all comes down to this. Separation equals resilience. Let's say a massively popular NFT mint completely spams and clogs up the C chain. Because of this architecture, your P chain staking and X chain payments will still work perfectly. This modular design is brilliant because it prevents a single viral app from taking down the whole entire network. Moving on to Section 3, Scaling with Custom Subnets, expanding horizontally. So, what is a subnet? It's a dynamic set of validators working together to achieve consensus on the state of one or more custom blockchains. An analogy helps here. If the Avalanche primary network is like the federal government providing a baseline of shared security, subnets are like the individual states. They can write their own laws, they can pick their own virtual machines, and they can even require their own specific gas tokens. Let's objectively compare these subnets to Ethereum Layer 2s to really frame these scaling philosophies. Ethereum L2s settle down to the Layer 1, which means they inherit full base layer security, but that typically comes with a 7-day wait for withdrawals or relying on highly complex zero-knowledge proofs. Avalanche subnets, conversely, settle to the P-chain. They borrow their security from the subnet validators and the primary network validators. So you are trading a little bit of that absolute base layer security, but in exchange, you get immense customization, no waiting periods, and total isolation from any main network gas wars. Fractions of a penny, $0.0001. Because subnets are isolated and dedicated entirely to specific apps or games, they can hit ultra-low transaction fees that are just straight-up impossible on a crowded, generic smart contract chain. And we actually have proven use cases validating this whole thesis. Look at DeFi Kingdoms. That's a gaming subnet that literally pays gas in its own Jewel token. No more competing with mainnet token swaps. Then there's Dexalot, a central limit order book exchange optimized purely for speed and getting rid of MEV, those hidden front-running fees. Shrapnel is bringing AAA gaming to the space using a permissioned subnet for managing in-game assets. And Meld is a DeFi subnet that features strict KYC, know your customer compliance, built right in for institutional players. It just goes to show one chain does not fit all. And with recent upgrades making validation more elastic, launching these custom rule sets is easier than ever. Section 4, the fuel, AVAX tokenomics, securing the Plural ecosystem. Now, what's really interesting here is how the native token glues all these separate pieces together. Roughly 60% of AVAX is staked for network security, leaving only about 40% unstaked or circulating. That represents a remarkably high degree of security, as validators are locking up a massive majority of the supply just to participate in and protect the ecosystem. So how does the actual utility break down? Well, AVAX pays for gas across the X, P, and C chains. For staking, you need 2,000 AVAX to run a node, which currently earns around a 7 to 9% APR, or you just need 25 AVAX to delegate. Crucially, for subnet collateral, every single subnet validator must also stake 2,000 AVAX on the primary network. On top of that, there's a burning mechanism. X and P chain fees are totally burned, and C chain base fees are burned too. All of this operates under a fixed maximum cap of exactly 720 million tokens. The big takeaway here? Every new subnet acts as a token sink. The demand for AVAX fundamentally scales up with the horizontal growth of this entire ecosystem. And finally, Section 5, the multi-chain future, comparing the giants. Let's zoom out a bit. When we put together an objective L1 scorecard, the picture gets really clear. Ethereum L1 offers ultimate decentralization. We're talking over 1 million validators, but it has a 12-minute finality and fees that can range anywhere from $1 to $50. Solana pushes extreme speed with 2.5-second finality and fractions of a penny in fees, and that's backed by around 1,500 validators. Avalanche C-Chain delivers blazing 1 to 2-second finality, 1 to 50-cent fees, with a validator count pretty similar to Solana. So looking at the data impartially, Ethereum wins on absolute decentralization. Solana wins on sheer base fees. Avalanche provides that blazing finality combined with its robust modular subnet architecture. So the big question, when should you use which network? Well, if you are holding millions in value and you need maximum settlement security, Ethereum L1 is your vault. For high-frequency consumer apps and super cheap NFTs, Solana shines. For deep DeFi trading, you might look to Arbitrum or the Avalanche C-Chain. But if you are launching custom app chains or you require strict institutional compliance, Avalanche's subnets are literally purpose-built for that job. The core takeaway is that tribalism in this space, it's just expensive. Sophisticated users and developers are going to utilize all of these architectures based on their specific inherent trade-offs. Which leads us to our final thought for today. Will the future of decentralized technology really be dominated by a single monolithic giant, forcing every single app to play by the exact same rules? Or are we going to thrive in a deeply interconnected, plural network, where thousands of custom chains collaborate seamlessly while maintaining their own sovereignty? Avalanche has clearly laid out a highly compelling blueprint for the latter. The only question left is, how will you build on it? Thanks so much for watching this explainer. Stay curious and keep learning. Catch you next time.